Once these are the volumes V1, V2, V3 like that, right? I introduced there are two methods, trapezoidal rule and Simpson rule to determine the volumes of soils in canals, right? You can understand this is A1, A2 and A3. This is D. You can see D is there, D is there, D is distance between distance between two areas, right? D to be same, D to be same. Area 1, area 2, area 3. D is the distance between two areas, right? Then you can understand, I think, right? Then we can see a exercise regard these two methods, right? Now we are going to a exercise regard the computing of volumes, right? Okay. Exercise 1, you can see distance 0, 30, distance D in meters, right? 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, right? Those are the distance D in meters, right? You can see the difference is 30. 0 to 30, here 30, here 30, 30 like that, right? D has to be same. D is to be same in this method, right? Otherwise we can't computing the exercise. Okay, D is to be same, or D has to be same. Difference between areas to be same. Area A in meter squared, the distance in meter, right? Distance in meter, and then area A is in meter squared, right? In so 0, distance 0, 1.3, 31.65, then 2.01, 2.37, 1.85, 1.61, 3.01, 2.65, 2.31, 1.02, right? Then we want to determine, we want to compute the volume. Volume means parimava in the canal, in the soil of the volume of soil in the canal, right? Volume equals, D by 2 under method 1, trapezoidal rule, right? Under method 1, D by 2, A1 first area, AN last area, right? D by 2 into A1 plus AN within brackets, and plus 2 into A2. A2 means A1 gone, A1 given, A2, A3 plus A4, A5, A6 like that. This is the last one. AN minus 1, AN minus 1. AN gone, right? N has gone means AN is here, then AN minus 1. A1 is there, then A2 only here. AN is here, therefore AN minus 1 only here. Okay? Bracket close. Then volume. We want to determine or compute the volume of the wedge, soil wedge. Then the distance D is 30. You see 30. 30 to 60 means 30. 60 to 90 means 30. Everywhere else is 30. Okay. Then D is, difference is 30 by 2. 30 by 2. Number 1 is 1.30. 1.30. Last one is 1.02. Last one is A1 plus AN. 1.30 plus first one and the last one. 1.02. Okay, right. Plus 2 into rest of the volumes. One is one given, one is taken, and last one has been taken. Then 2 into 1.65, 2.01, 2.37, 1.85, 1.61, 3.01, 2.65, 2.31. Okay. .31. Last one is 2.31. No? smart type, then last one is bigger smart type. 2.31, right? Last one is here. See, this is the first one A1, last one AN. Then from the second node we can start 1.65. This has been given, formally taken, right? This also taken, 1.02 taken. Then 1.65, 2.01, 2.37, and last one is 2.31. This is here, okay? 1.02 is here. Last one in this bracket is 2.31, okay? Then the volume, you know volume in meter cube. This is area, distance in meter, area is meter square, then volume is in meter cube, equals 556.8 meter square. Okay, right, answer of this. Then I have done in number one method. First one, you can calculate under second one Simpson rule, right? See, n is even here, 1 2 3 4 5 6 7 8 9 10. N equals 10 means you can do this under Simpson's rule. Okay, you want to do this. This is the exercise for you. Okay, n equals 10 means this even or irate. Then this sum can be done in the Simpson's rule also, as n equals 10. This is an exercise for you. You want to do this, right? Okay, and you can check whether you can check the two answers. This is 556.8 in trapezoidal rule. You do this sum in Simpson's rule and check whether it is very near to 556. It is to be 560, 580, 550, like that, right? This answer to be equal to this, equal or very near to this. Okay, volumes in two methods. Therefore, your answer is for you. Your answer to be very equal or very nearby to 556.8, right? Like 560 or 540, like that. It's okay. That's all, right?